Hello YouTube, Random's House here, and today I want to show you a one-day build. This is a USB pass-through light actuated Arduino controlled relay. This project required 3D design for the case, circuit design, and C++ programming to get it all to work together. The purpose of this project was to get my USB powered T-lights to turn on automatically at night. And if it's an overcast day, if it gets dark out a little early, it'll automatically kind of adjust to that because it's based on light. It's got a photoresistor in there that's measuring the light intensity outside. And conversely, at dawn, it'll automatically turn the lights off. In the previous clip, you see me put my finger on a sensor on the device and the lights come on. That's the photoresistor. It's measuring the light intensity, and that simulates darkness. So when I put my finger in front of that sensor, the lights will cut on, and when I move my finger away, the lights automatically cut off because it sees that it's bright out again. So it's daylight, so the lights don't need to be on. For this project, the first thing I had to do was design the circuit and figure out all of the components needed for this. In this case, I need a USB female adapter, need a USB plug-in, I need a photoresistor, an Arduino Nano, and a relay. The next step of this, I needed to design the case that this was going to go into, and the first part of that being the way to attach this to the wall. Which essentially for this one, I'm using a couple hooks to hook onto the cable for the surge protector that I'm using to power the device, so that it can hang from the surge protector and I don't have to drill any holes or screw it into anything that's out in our lanai area. The next part of the design, I needed to actually make the box that it's going to go into. So here you can see me in Tinkercad constructing the case from solid boxes that I'm dropping and manipulating the shape of. One thing I did as I made this box is I created some dummy shapes in the same dimensions as the Arduino and the relay, so that I could just make sure that the box is actually going to fit everything. It's one thing to take measurements, but to see the components inside the box makes it much easier to make sure your dimensions are right. And then also I wanted a little bit of tolerance on the outsides of the components so that I have room to manipulate the wires or get in there to move things around. And it's just easier to visualize it by making these dummy components that I can put inside of my, my 3D design. And then of course I created the holes for all the cutouts. So the power wire going into the device, the female USB plug-in, and then the photoresistor cutout. And that way I don't have to use a drill. It just prints it correctly from the start, and then I just stick it in and glue it down, and I'm good to go. And then for drilling or for mounting the components in there, what I did was I measured where the holes were at on the relay and then the Arduino. I put those holes on my dummy component, and then I place the dummy component inside of my case, and then I let it delete the exact same spot in the case with the dummy component in there. So I measured it on the component, and I let the program figure out exactly where to put those holes into the box so that it matches up exactly where I wanted it to be at. And when I created the hooks, I created a dummy wire basically with the same diameter as the wire that I was gonna actually hook onto in real life. And this way I could test them virtually before I have to print it out, because it does take quite a while to print all these components, on the order of 10 to 20 hours for each component. So to avoid a lot of reprints, I tested this by creating the wire and then just making sure the measurements fit around it. And then of course, a very important part is how do you connect the lid and the body of the case. So what I did was I created these little tabs on the lid and the body, and then I just used an M3 screw to connect those. So 4 tabs. And then again, once I was done with that, I virtually put the lid on top of the case so I could make sure that all those holes line up, and I don't have to have a lot of reprints on this. And then once I completed the design, if you're not familiar with 3D printing, you've got to slice it. So this is my slicer program, and so I dropped the objects that I created in Tinkercad into the slicer. And then for this one, since it doesn't have to be perfect, it's just a box, it doesn't have to be pretty, so I made the layer height about as big as I could get away with and still have a functional print, which is 0.28 millimeters. Typically for prints to look good, you're going to want 0.1 to 0.15, but the layer height didn't make a whole lot of difference to me since it's just some blocks. Next, I've got to 3D print my case that I just designed. This is a time-lapse video. It took about 24 hours to print the whole case. next step was to prepare all the wires. So you can see me cutting them out.
Gonna go to DC minus.
After I prepared the wires, then I had to solder everything together and connect everything to the relay in the Arduino. I used heat shrink here to help avoid shorts. Once everything was wired up, I pushed the photoresistor into the photoresistor hole and glued it in place with a hot glue gun. You can see I had a lot of trouble with the female USB end. I had stolen it from another device, basically an old battery that I broke apart. Removed the USB end, and the metal connectors were actually coming undone, and hot glue didn't seem to work. So I finally just used a whole bunch of solder to hold it all together. and then I glued the female end into the case. For reasons that will soon become clear, you do not want to do this. Don't follow my lead and solder everything on the female USB plug. It's not the best strategy. Now that I've got it wired up and ready to turn on, I need to write the code and program it. Once we program it, then we can see if it works. The code here is pretty simple. It just takes a reading off of the photoresistor to see what the intensity of sunlight is, and then it outputs a signal to either turn on or leave off the relay. Alright, so I just wired it up and I'm going to test it. So if I plug this into the outlet, it will get power. So it's sensing light. The relay is not closed. It looks like it just lost power. And there is a light flickering, making a beeping sound. I suspect I shorted it out when I soldered the USB port. Alright, so I just removed that USB plug because I'm pretty sure I shorted it. Luckily it didn't blow anything. I don't think it did. Let's see if it works. Or let's see if it's not broken, I guess is a better way to put that. Wow, works. So you can see when I cover up the photo eye, you hear it click. That's the relay based on the amount of sunlight it's getting. So if I point it at the sun, it should just stay open. So, didn't break it. Now I need to find a USB plug. Alright, the new USB end is in. let's button it up and test it out. Looks like it works. There's the lights that it's supposed to control. If I turn the photoresistor towards the light, they go off. If I turn it away, they go on. Alright, now I just need to package it up and put it in operation. So it's obviously not supposed to flicker like that. The reason it is flickering like that is because in the code I told it to turn on or off at exactly 500 millivolts in the signal going to the Arduino. So that corresponds to a very specific light intensity, and in real life, as it's getting darker, the light is not 100% steady, so it's gonna oscillate just like everything. And so as the light is slowly decreasing and oscillating, it goes above and below that 500 value very quickly, and then you cause your relay to cycle way more times than it needs to cycle. So that's going to reduce the life of your relay, so you don't want to do that. The fix is pretty easy though. If it's off, then the light intensity needs to be less than 400, and also I put a variable in there for the lights being off. That way it doesn't actually have to measure it each time. If you measure this thing too fast, so if you're measuring it 1,000 times a second, you could potentially drain the voltage and cause inaccurate measurements, which is also why I have a 100 millisecond delay in there. So I don't want to measure it more than about 10 times a second, just so I don't actually drain that signal wire of current or voltage. And then I say if the reading is greater than 600, so if it's getting brighter out and the lights are already off, the lights will come on. There's an overlap in there. It's got to be below 400 to come on, and it's got to be greater than 600 to go off. And that overlap prevents that oscillation and normal light intensity from causing it to flicker like you saw it.